Hello and welcome to the class on correlation. Correlation is a statistical technique which measures the degree to which two variables fluctuate with reference to one another. Correlation denotes interdependence amongst the variables. The degrees are expressed by coefficient that ranges between -1 and +1. The direction of change is indicated by positive or negative sign. The positive sign refers to the movement of two variables in the same direction, whereas negative sign refers to the movement in opposite direction. An absence of correlation is indicated by 0. Correlation indicates relationship between two or more variables. It is also known as covariation. The relationship between two variables can be of two types: mutual dependence and cause and effect relationship. A type of relationship between two variables where a change in the value of one of the variable brings about the change in the value of other variable is known as mutual dependence. For example, oxygen consumption and metabolism in an organism. If there is increase or decrease in oxygen consumption, there will be increase or decrease in metabolism. Similarly, if there is increase or decrease in metabolism, there will be increase or decrease in oxygen consumption. A type of relationship in two variables where the change in the value of one variable is the cause of the change in the value of other variable is known as cause and effect relationship. For example, rainfall and crop production. The types of correlation can be categorized as positive correlation, negative correlation, linear correlation, or non-linear or curvilinear correlation. Increase in the value of one variable results in increase in the value of other variable, or decrease in the value of one variable results in decrease in the value of other variable denotes positive correlation. Here we can observe positive correlation and perfect positive correlation with the help of scatter diagram. Whereas increase in the value of one variable results in decrease in the value of other variable, or decrease in the value of one variable results in increase in the value of other variable is known as negative correlation. We can observe negative correlation and perfect negative correlation with the help of scatter diagram. Whereas the temporal data of two variables can be denoted with the help of correlation graph. Similarly, the scatter diagram as shown here indicates no correlation between the two variables. Karl Pearson's product movement correlation is defined as the ratio of the covariance between variable x and variable y to the product of standard deviations of variable x and variable y. It is also known as Pearsonian correlation coefficient, which is denoted with letter small r. Symbolically, correlation is denoted with the formula Rxy is equal to covariance between x and y divided by standard deviation of x into standard deviation of y. Rxy is equal to Ryx, where Rxy or Ryx can be obtained with the given formula. The Spearman's rank correlation coefficient, denoted by small rs, is the non-parametric version of the Pearson's correlation coefficient. Sometimes we may not know the actual values, but their ranking may be known. In such occasions, Spearman's rank correlation can be used. Even when the actual values are available, we can rank these values and measure the correlation using Spearman's formula. Here, the data must be in the form of ordinal, interval, or ratio. Spearman's correlation also ranges between -1 and +1. For example, if the sample consists of a series of n pairs of x and y values, replace the observations of two variables x and y by their ranks. For example, replace x1, x2, x3 up to xn by the ranks from 1 to n according to the values of x in the ordered set. That means the smallest value of x gets rank 1 and the largest value of x gets rank n. Similarly, replace all the values of variable pi by the ranks from 1 to n. Spearman's rank correlation coefficient is identified with the given formula, where Rs denotes Spearman's rank correlation coefficient. Small d is the difference in the ranking of the two series x and y. Summation d square denotes the sum of difference squared values, and n is the number of pairs of the data. If the Rs takes the value +1, then the individuals have the same ranks for both variables. Now if it takes the value -1, then the rank order of one variable is the reverse of that of the other variable. If the Spearman's rank correlation coefficient is 0, it indicates that the two variables are not associated. Thank you.